versions of Kubernetes.
I wonder if this check product will actually be able to looking into those as well.
Yeah, it does. It does a lot of like searching online, reading the repos, reading the release notes. They have humans in the loop. They have a lot of things. At least when I saw the demo.
Right.
Okay, so let's jump to the book. I think I'm showing the book already. Chapter 6, self-service. This book, this chapter, I read it. I thought it was going to be a lot of backstage when I started reading. Read the title and the first, but it's not. It's more than that. Backstage, the UI thing, but I think it talks about the concept of self-service and high availability and resiliency. And there's some YAML files shared. I think it's in the repo under chapter 6 folder that you can use for like illustration purposes. But let's start with the first topic of like it talks around the software cycle of a software SDLC of like for the app. It's not the same for the cycle of like the platform team with the assets. I think it was very, very good to highlight this. I have not seen this highlighted in other books. For example, who wants to expand on this? Who wrote this chapter? Maybe
I think it was primarily on Andy.
Okay.
Yeah, but no, I mean, like we always discussed about that. You have different layers in the platform engineering perspective, and the software is always moving differently than the platform does. And you could also say like there's also the infrastructure beneath it, which even moves in a different behavior pattern than the platform itself. So what we quite often see is that people try to integrate everything into one, and then comes up this question like we had it just right now. It's like, how often do you upgrade your Kubernetes? I think that's the wrong question. The question is why you can't just upgrade your Kubernetes. What you have built, what you have done wrong that you have so strict dependencies to Kubernetes that you cannot upgrade.
Yeah, so it's actually me that wrote this chapter, and there's some weird button in the bottom left of the UI that if the window is not scaled
the cookie
correctly,
button, right?
It blocks the unmute button. So I'm trying to figure out where is my audio button, and I'm like, this looks like I realized past cloud engineer, I was like, this is a responsive design issue. Let me scale my window until the mute button shows up.
Yes.
But yeah, no, I mean, obviously Max hit the nail on the head with what he said. And really what I was thinking about when there are so many diagrams that didn't make it into the book. And one of them was me trying to figure out, okay, how would you draw the software development lifecycle of a platform? And the moment you try to do that, it expands like tenfold, because it's like, well, how many aspects do you have of your in your platform? Like what is in there and what is not in there, and what are you even lifecycling to begin with? So that was why I made that point exactly, which is just, if you think of it like an app, you're missing the mark, because it's so much more than that. But you still have to have that product mindset to your approach with it. So you can't not plan for life cycling. You can't fail to iterate, right? So that was, and then of course everything that Max said.
Yeah, and I like the as code in the middle here for the CI/CD DevOps test, and I see that the devs are pointing to the source code and the static analysis, and on the right side I don't see a devs on the production environment. That was interesting, but it shows up in the next diagram. The developer with an arrow to code, and I think logs and metrics and traces.
Yeah, and it's just, this should not be representative as a source of truth. It's just an example of what access might look like. So, for example, in my working environment, the developers don't have access to the logs and metrics and tracing.
you mentioned
S3
it
only
before.
has that. So that depending on the regulatory status of the environment you work on, they may or may not be cleared to see these things. So where I work, and how I work, the S3 team has access to all this stuff. We are given the clearance and the authorization. We go through a bunch of additional rigorous training. But actually, like, the devs don't have access to that by default.
And what will be the solution, or like, does the devs need access to the logs, or yes or no? And if the answer is maybe, in that use case, you get them partial logs, sanitized logs, or
Yeah, so
no
we
logs
talk
at
about
all.
it later in the book, which is that,
Okay.
so notice, like, the S3 has access to the production environment specifically, right? We're talking
Yes.
about, like, if we look at the pre-production production environment, you should ship sanitized logs out of the production environment into something else, either a centralized observability system or something else. So basically, ship what you need out, don't give people access in.
Yeah, and the idea of, like, I don't know, what was, like, the manifesto of, like, the more you can avoid the dev needing logs from production environments, and they can do everything from pre-production environment, looking as much as possible as production, right? That's why you have a pre-production, like, to
Yeah.
test, and if there's something wrong, well, it should be wrong in pre-production, but life is not perfect, right? But as much as part, like, but design for that pre-production, that devs absolutely don't need access to how many logs from the app in production Uber has in the last 5 minutes, right?
Yeah, exactly. So design for least privilege, right?
Yeah,
They should only ever
exactly.
have the things they need and never have the things they don't need. And then, there's ways to, grant temporary access if you really need to, or, push things into a place where people have access that is appropriate. There's 5 million solutions for least privilege. Pick one and go with it. But yeah, ideally we find everything in pre-production. Reality is stuff happens.
Yeah.
The number one thing that I see happens is all of the pre-production work never really proves out how your software behaves when it has longevity. So how does it work when it's been running for 2 years or 3 years? You really can't test for that, but that's where I see the most interesting failures, is when you have things that happen purely just due to the age of the thing.
Purely for
So
the age.
that's really the things you're going to find in your best tested, perfect environments where everybody is following every best practice. You're still going to see something that has to deal with longevity. It's going to happen.
Okay, I see. Yeah, and I love that. I will say one more thing, that I like the clean diagram. I'm not going to. The last thing I was going to say, like, I went through this process recently of, like, writing architecture for landing zones with Terraform and Argo CD, and we went back and forth, and I think we landed on something like this: like, it's too complex to write, like, a guideline or white paper and have all the possible scenarios of, like, because people say, well, we have, like, 3 production environments, and then we have the pre-production environment, and then we have the pre-production -2 that we haven't, like, we created to replace the pre-production one, and then we have staging and test and UAT. So I think it's a good simplification to start with. Like, you have prod and pre-prod, and then people can start from that, extrapolate from that.
Yes.
That's something that debate of, like, since this is a book for architects, right? That's something that we went recently.
To Hillary's point, people don't always test to verify that their certificate refresh process runs correctly. And so they find out a year after the fact, when their certificates all time out, that things break. And so these longevity things are nightmares, because they're things that you know about, but because it takes a year to manifest, you forget about. Unless that's all solved, but with the new release.
Well, and I think that's the thing that everybody thinks will happen, is now that we are in the cloud and we have things like GitOps and CI/CD and so forth, we're like, okay, yeah, that'll happen, but only if the environment's up for 3 years. It'll get upgraded before then, surely. And that is the biggest like fallacy we have in this environment of computing, is that we think the upgrades will happen on a regular cadence. And by and large, that's true, but it's not a universal truth, and we treat it like it is.
That's true. And then you have here an example. I like this diagram of the
I wanted
example.
to ask one
Go ahead.
question, just something right before you move on to that diagram. There's a concept called serviceability that I found really interesting, reliability versus serviceability. Hillary, if you want to, yeah, I don't know, talk about this a little bit. It's not something I often encounter with, I guess.
Yeah. So this was. I mean, for something to be serviceable, it should be reliable. People should be able to count on it. But just having the thing up doesn't mean that it's doing the job they need. And so serviceability is more about putting on the product mindset and thinking about the golden paths. Like, who are the people who have to
yeah.
use this and what are they doing? So reliability is something that's almost, it's a little bit organizationally personal, in that you may have a greater fault tolerance in one organization versus another. But overall, the concepts behind that are pretty similar, because it's just like, okay, we want 90% uptime, 95% uptime, etc. Right? Serviceability
Yeah.
is very much. I'm struggling with the word I want here. Someone's going to immediately chime in because their grasp of English was better than mine. But it's very much like personal. It has that, like, what people find usable is definitely going to be more organizationally specific to who the people in the organization are, what their behaviors are, what the business model is, who are their customers.
Do you think serviceability should challenge this as well, the behavior of the whole software developer organization, or should it follow the common behaviors?
Little column A, little column B. I think we talk about this many times. A good platform challenges Conway's law, right? So and for a platform to be successful, frankly, there's going to be compromises in some places. Some people are going to have to change. There's the technical aspect of it, of needing to drive cultural change, challenging Conway's law, and trying to improve upon what already exists. But you can do that iteratively, so that you can make changes more gracefully, so that people are not having a couple of really bad sprints where they have a major paradigm shift and they're trying to get used to something completely unfamiliar, and it just like breaks their brain, kills morale, and makes everybody frustrated, right? So there's a strike the balance. The other thing is that serviceability should inform reliability as well. So what your fault tolerance is, it will help you to determine your reliability metrics. So a good platform challenges Conway's law and helps people to work better, but also strikes a balance of meeting them where they are. So there's a little bit of like, there's some things that the platform doesn't need to do. There's some things it does need to do. There's places where both things are going to compromise from, where individuals might think they ought to be. And that's just, working with humans. So the serviceability is more the socio-technical aspect, versus reliability is really just a technical factor.
That's cool. I like the phrase, to be honest. Thank you.
Yeah, and it's captured in this paragraph of like reliability could be considered measurement of the serviceability, and then talks about the serviceability comes from the service, right? You're providing a service for like meeting the user's demand, and then that service, can I use it myself, right? It's a self-service. That's where, like you're saying, the user's ability to accomplish all the actions without relying on a governing team, like on blockers, right? That they will be blocked X amount of time to do something, to accomplish what they want. And I don't know if you folks have examples for that. I had one recently this week discussed where, on the topic of add-ons, right, and upgrades. I think it was they use. I'll pick one atom so people have examples. Like it's good to talk about examples like Open Gatekeeper. So they want to upgrade the version of Open Gatekeeper. So the team that is going to like put it available for new clusters being created going to use the new version of Open Gatekeeper. And I was told that in this organization,
You mean OPA, right?
yeah, OPA Gatekeeper, like that Helm
Yeah.
chart, right?
Yeah.
And the is self-service to a certain degree. So the person will put in a request in a system saying, this is the version that we want, which is the new one. They put that request in I think the Jira ticket open or some system opens, and then they have to wait for procurement process to happen. So someone service owner that owns the Open Gatekeeper approval button needs to physically review the release notes, whatever scanning they do, and that sometimes is manual process. And then the person told me that and I click the button, says approve. So it's not very. Then they have using Argo and everything. That they have automation to deploy it and everything, but that step of like updating to the new process doesn't have automation in place for that team that wants to get the new version or like certify the new version. That's just one example. I don't know if people have other examples on like self-service or blockers that will occur under self-service. Like I don't think there's things can be done like self-service or from the beginning. So the golden path. Where does the golden path concept comes in? Any thoughts, Max and Hillary? Like that naming convention of golden path. I don't know if you want to illustrate folks, or like maybe some people don't know what golden is. Like, is it golden versus blue or silver versus like what is the path and what is golden?
So this comes from like some product management, project management, like works and writings that you can find across the industry. So it's a product management term. Um, Golden Path. I've also seen critical user journeys. We use both in the book and talk about them in kind of similar ways. But it's basically just I'm gonna reduce it. It's basically a buzzword that I figured people are going to be largely familiar with because it's something. It's a buzzword that's been around for like I feel like 10 years. I don't actually know. It feels like a long time. But that concept of a golden path is um, similar to like when you're doing your quality engineering testing and you're like, what is our end-to-end workflow, right? If I'm a quality engineer and I'm testing a system, I have to think about, okay, well, how does the user move through the system? How is the system navigated by the personas? And then that's the flow that I test. And so that flow really needs to come from the product and the product management, ideally. Although, nothing's ever perfect. I've had to develop those myself. And it's basically like, okay, here is how this system how people will use the system. So, and if you're thinking about how people are going to use your platform, then you're putting that person first mindset versus the technology first mindset, right? It's not just infrastructure, it's something that people want to use. And that helps you to be making sure you're building the right thing. So if you're building for developers, right, how are they going to use this? I don't remember if it's in this chapter or a later chapter that we first talk about user interviews, but understanding what your golden path might be is going to require some research. You need to go talk to the people you're building for and make sure that you understand how do they work today and how would they like to work, right? What would they want to have be better? What would they want improved? And so that you can start thinking about the workflows that your platform needs to support. And the golden path is like the most critical one. So your platform can do a lot of things, right? I think we talk about like is infinite technical feasibility, but then like driving down to like what's feasible, what do users want, what does provide that business value. And then I think Max called it like defining a purpose, right? In one of the earlier chapters. the golden path, the purpose, the critical user journey, these are all kind of really similar concepts. It's just this is a specifically like the exact way through which a user will move through the system during their end-to-end interaction. And ideally, that may just be I push a pull request, and if pull request gets approved, and then that's off to the races. Everything else is automation. You may not be there immediately. You might get there eventually. You may have certain manual gates for various like business reasons or regulation reasons or some other reason. So it'll look a little bit different. Again, it's a kind of one of those it depends things. But the idea basically being the golden path is how your users are moving through your service and interacting with it.
Yeah, and in this case, also, I guess people can, or the platform team can, like, as they like design or architect this golden path, they can start extracting that what will be the interfaces, right, for that developer. So in this case, if you want to go strict with whatever is draw here, I can see that the developer has one line to pull request and one line to logs and metrics. It says observability. And there's no more lines. There's no line to Kubernetes. There's no line to Argo CD. There's no line to Tecton. So this could be an implementation that a platform team can achieve, right? Of like this person writes code, sends pull requests, should never troubleshoot Tecton, should never troubleshoot Argo CD, should not troubleshoot, inspect if the SPON was created this week correctly or not. Hopefully they're not evaluating that. And then the application running in the production environment, right? He may not have access to, like you were saying, to those logs or to SSH to that application. He has a view of the observability, but it might not be the direct one. Like that line that you mentioned from application production to the logs that they see is like a distilled version, or maybe the version that they should not be looking, or maybe looking at here at the environment that the application is running on pre-production. So you can get out the interfaces, and this is a common thing that at least in the space of the DevOps for Kubernetes, right, having CI, CD, pull requests, and the developer. This is kind of like the archetype that I see all the time.
Yeah, and it's again really simplified diagram. You know, like you said, there could be permutations on this where the developer does have access to Tecton or would inspect the SBOM, or the SBOM would send something informing back to them. Like there's a bunch of different but eventually it just starts to look like a bunch of arrows and not a workflow. So just really reduce it down, simple, just to really get you thinking about exactly what you said. Like, what are the interfaces? What are this person really going to need and not need?
Yeah.
So Carlos, I got a quick question. Yeah, so the Tecton is generating this SBOM, right? Is that correct?
So again, grossly simplified. So Tecton would have a job that would trigger something that would do the SBOM.
Okay, but is the SBOM something that's generated? I guess where I'm headed with this, right, is that SBOM persisted like in a repo after the generation, so that we have some kind of auditability track on what was generated?
Typically, I would say yes. It would be persisted somewhere. Again, grossly, very highly simplified diagram, but yeah, okay. you would typically need your SBOM to deliver it to a location, and it would go to whatever location is appropriate. So it could be thrown into Git, could be committed back to Git, like you mentioned, could be put on a server and then like pulled down on demand if needed. It just depends.
Yeah, okay. People put it with the image in the registry. Some of the they sign. And also the SBOM, they put it as a layer, or like it'll be a companion to the image. So then later you can like inspect. It's closer to the image, right, to the artifact that is signed, that is hashed. And this is the SBOM that declares. And people don't know what SBOM is. Built on material. Like, what is the S for?
Software.
Software build materials. Yeah.
Yeah. So and there's a PDX, and there's like two prevalent formats of that document, and there's tools to generate it when you build your image and your software. You check for like if it's npm, you check for all those things. So yeah, and that's typically what is safe there as SBOMs. Good question. Sevi, you were going to ask something before we move on?
The conclusion part had a really nice paragraph that resonated with me a lot. Your developers will need the ability to leverage these systems both transparently and opaquely. So it's about the visibility of individual pieces and like what's happening in them, because and even debugging issues within the system. And that's so important if you have an IDP or like a platform. And then if something breaks, this is, I think, basically related to reliability and serviceability both.
Yeah.
I think this was very well put.
Yeah, for example, here's in taking a CI job, right? Just what it could be Jenkins or it could be GitHub Action. But imagine yourself that you have a pull request in, let's say, GitHub, and you push something like this is the open source software way of doing things that will trigger the GitHub Actions, right? To run the test or LinkedIn or whatever. Imagine if you don't have access to the jobs, just it failed. Right, you as a developer, like, we failed, why? Like, the last change that I did, like, give me the logs, and that give me
I didn't know how many times I had spent, I don't know, a day, half a day, because common build was failing for about a different problem, and I was just there at that time of the day.
So it wasn't your fault, it was something common.
No.
Interesting. And then this one, it was very interesting, of like the cognitive load, and also this table that puts the persona of like sometimes not like a straight cut of like platform team is in charge of these things, and then the development team is charged. There's sometimes a shared responsibility model, right? I don't know if somebody wants to expand on this, on some of these examples.
I mean, you kind of said it, right? This is not, there's no universal truth. I really want to make that clear. Like, these are just illustrative examples. You could find that these things move around. You could find that there's things that I didn't include in the table that you can think of, right? The purpose is just for like the idea of illustration. And it's going to be also very based on the maturity of the organization, of the platform engineering team, of the development team. So
I like this one, to expand on this one. An example, platform upgrades. So we'll pick one that we were talking at the beginning, EKS or Kubernetes upgrades. So it's not surprising to me to talk to a lot of end users that are called, we are the platform team, and we need help upgrading these many clusters. And then after this discovery, and so like, we'll go ahead and upgrade them. Like, we have tools, scripts, buttons, insights, all those things. Like, well, the way it works is these are our clusters, but we develop the Terraform module that we give to the development team. When they want a cluster, they just run the Terraform that we maintain, but we don't actually run the Terraform. The development team runs the Terraform when they want a cluster, and they run that Terraform when they want to upgrade the cluster, and they don't want to because their app is still running fine and they don't need to upgrade the cluster. So help us. Did that situation have come up, or like it's a common thing for other folks? It's called the infrastructure as code as templates. Maybe it's called. I don't know what name to give it.
Blueprints, maybe.
Yeah, blueprints, infrastructure as code, templates as a service, module as a service.
Boilerplate is another one I've seen it called.
Oh yeah.
So Hilary, had you seen that, or Max, or any other folks have seen that in the field happening? Of that perception of like, I own this task, but then you dig down and like you own it or not own it? Like, who owns the cluster? Is it the app team, or is it the platform team? Like, who's in charge of upgrading the cluster and the add-ons, right? And these organizations are so vast, right? That's why they need a platform team.
I think in the shared responsibility model, you have to assign who's accountable for that piece of component, I reckon. Otherwise, in the shared responsibility model, you might just suffer.
If I could ask a question.
Go for it.
Yes.
Okay. So I'm looking at the list, and in my former organization, we had this back and forth about database management.
Good one.
No,
Yes.
database needs to be external because Kubernetes has its own frequent upgrade cycle. Databases have a different upgrade cycle. Keep them separate. And then it's no. There's all these fancy controllers now. Postgres works great in Kubernetes, integrated in. And so there's a back and forth on that. And so for us, the database became I believe for us a line item on the platform team's list here. Is database implied in here, or are you covering it separately?
I would say it's implied. It starts getting, like I said, the list starts getting unwieldy if you start trying to think about every single thing.
Oh no, I understand. We just have so many schema changes that are in different cycles from underlying software changes, and so the schema has to be changed way ahead of the software. There's all these different cycle things, and so it's just another layer of complexity that's implied in here. Okay.
Yeah, if you start getting into database management, we have a whole second book.
Okay.
That's
cool.
We have a whole second book at that point, right? And so if you're like, oh, we didn't really talk about it, it's probably too deep,
right?
And probably too organizational specific.
No, it's true. It is a Kubernetes debate about, do databases belong in Kubernetes, and I have actually heard that that's a settled debate, and I've also heard that it's not a settled debate, and so I just wanted to get your perspective. That's all.
Yeah, the answer is it's complicated. There are some great Kubernetes databases, like you said, Postgres works great. There's the Couch database operator, CockroachDB. Apparently, I've never used it. Apparently, fantastic. There's also tricks that you can do with versioning your data, right? So if you have an API update that involves a data schema change, you can version your data. And if you have a different table for the different version, you've got some joins, then you can also do rollbacks more easily, because then you go back to the previous API and it starts writing to the original database, and you handle your schema change that way, and eventually you can roll off your old data and you're all in the new schema, right? There's so many things one can do for databases and management, and if it's like who's responsible. I've seen companies that had database administrators, and it was their responsibility, and they do everything because they are the experts. And then I've had companies where the developers just find out the hard way by running face first into problems. There's no like cookie cutter model of operating, and databases scare me.
Yeah.
Frankly.
Yeah, you can write a whole book on this. So many strategies. So actually, yes, the things that you mentioned is worth a book of talking about upgrading strategies for databases, right? I wonder, like, if there's the need for a book to sound like Kubernetes upgrade strategies, because it's similar things, right? Of like this concept of like coordination, right? That and the problem comes from fear. Like the development team it can run that Terraform to upgrade, but it will ask the platform thing, hey, that Terraform that you gave me, if I run the module, or I need to go to this factory to upgrade to the latest version on the module, and then I do a Kubernetes Terraform up. I'm just saying Terraform because that the one, it could be Pulumi, it could be whatever. But the platform, the development team is asking just as a fear, like, would this affect or break the application that is running in production? That's the lining, right? The ultimate lining of asking, like, I'm willing to upgrade it. My app is running fine. Do I need, like, would if I upgrade, if I do the upgrade, would my app be suffering? Like, will something go wrong? And the platform team, like, we don't know, we're not sure, right? Because it might be that they don't have pipelines, and they never did. They don't have a staging environment. They don't have a pre-production, or even they have pre-production. They even ask, like, wait, it works on pre-production. How much confidence do we have that this will work on production?
Yeah.
I think that is a good idea for writing a book with some psychologists together.
Yeah, seriously. What I see a lot is, and I think this is I think this is an anti-pattern, because it reduces your failure domains down to everything has the same failure domain. is I see customers with very large clusters. And so they've put
Okay.
all of their lower environments, their dev environments, their pre-production environments, their staging, integration, etc., even load and stress testing on the same cluster as their production environment.
Oh,
And then and so there are even people who advocate for this as a model, like one big cluster that does it all. The problem is when you have one big cluster that does it all, you have one failure domain, and your one failure domain hits absolutely every single aspect of what you're doing as a company. So the reliability engineer in me, the first time someone told me that, I was horrified, and I said no. But this is a cost saving measure, apparently, quite frequently, to try and reduce expenditure to do this. So I think that's where some of the problems are, is we actually see that really, really frequently, where it's one cluster for everything. And that makes it, that is where a lot of the fear of upgrades comes from, is we have no way of knowing if this works until we do it.
that's true. That's true. And the question comes a lot. The same thing, like, what do you recommend? A lot of many small clusters, right? One for business, line of business, or put all the line of business on a large cluster, right? And I think some of that comes. I think the most of it comes from cost, right? It costs more to run 100 clusters that is to run 10, and the thing or the aspect that have changed lately, at least that this is my perception, I could be wrong, is that in the past, and I come from on premise, I did a lot on premise, my previous cloud provider, but now I'm on the cloud. And it's what, because Kubernetes was configured where static nodes of, like, you selected the size of the nodes, and then you have to have more than one to have redundancy, right? For these apps and these availability zones. And then you select a size that is big enough for growth, and then that will cost X. And if I create 100 of them, it will come X by 100. And lately, with more advanced, I think, strategies, software, people coming together to talk about dynamic scaling, things like at least the one that I'm familiar, Carpenter, which is available in AKS, and the ability to beam pack better, of, like, you don't have to, certain cases, you don't have to worry about the size of oversizing, that the workload will be maximized for the usage of, like, what is using. So the nodes become very small, just enough to run the applications, and they would adjust, and nodes will come in and out, or you can create more. And then the second wave, which is in 133, the ability to do dynamic pod resizing, vertical scaling. I think that would at least alleviate some end users to say, I'm comfortable running multiple clusters, not that expensive, because I'm using this node auto scaling, even cluster auto scaling, right? Cluster auto scaling, Carpenter, AI, or advanced metrics to set the right requests, right? A lot of people just put, like, give me 5 CPUs for my pod in request. Like, you're actually never using 5. You're using like 1.5 for the last year. And then analyzing that and going back of, like, reducing cost optimization. I think people are, like, comfortable creating multiple clusters, many clusters than in the past. But some end users are not aware of those concepts. So they're, like, have that mindset, like, it's costly. So I don't know if that's what people think about that with the new scaling tools. Is it helping to that perception, or maybe not helping that much?
I don't think it's helping yet. I think it depends. I think you have people who are in various stages of maturity. I kind of see, as one of my colleagues put it, we have some people who are, well, let's rub some Kubernetes on it and see if that solves the problem, right? And that's their level of maturity. And then we have, like, Kubernetes power users who probably have forgotten more about Kubernetes than I have learned, right? We have the whole spectrum out there still. So, and then of course, being a reliability engineer, the people who end up in situations where they need help from me, there's like a confirmation bias. It's more that first bucket, right? people who come and ask me questions, or for whom that we are interceding. Whereas the second bucket, they exist. They're likely the majority of our users have never actually gone through and tried to figure it out. That would be ethically questionable. But we don't hear from them because they are
Of course.
power users and they know what they're doing. They're very mature. So I can tell you what I see, but also like that's confirmation bias because I'm going to see the people who need help.
Yeah, exactly. For me, like I don't get called. My experts don't call me that don't have any problems.
Yeah.
The majority of the yeah. So I agree. Like from having bias, I can say I never talk to people that like are experts and have like been packing like to the teeth, right? All the customers or end users that I talk to are like problems that people that need help. Well, that's my job to
Yeah.
help them. I guess
In the past, I had customers who didn't care about costs at all, but only about ownership of these costs. So they didn't want to have multi shared clusters with
Multi-tenancy.
different because they were at that part of their migration journey that they really wanted clear separation. But then I've seen multi-tenant cluster model working amazingly with 200, 300 nodes, like everyone just uses the same. Not just one cluster, but like really, really big clusters, shared clusters. So I think it really is different in different sizes and of companies as well.
And Sabi, also for people way in the past, right, that were trying to do multi-tenancy, they couldn't allocate cost to these things. Move forward, actually, there's technologies to do attribution of this namespace is costing X, or down to the deployment, down to the pod, down to the container, right? How much CPU and memory, how much network bandwidth it's using, and if it's connecting to a object storage or it's connecting to a database to associate that object storage and database back to that container, back to that deployment, back to that namespace.
Exactly. It was really painful and close to impossible in the early days, right?
Hey, can I ask a question really quick before we wrap up? I know we're getting close on time, but I'm really interested to hear this. The platform availability in the both category, I'm curious to hear why that's a shared responsibility.
Because you need to be a good citizen of the platform. And I actually do talk about this later in like the care and feeding of etcd, being protective of CPU and what the platform team can do to help ensure that the shared resources that could take down the entire platform do not get abused, things like quota and so forth. But at the end of the day, as a developer on the platform, you need to be a good citizen. So don't do things that are irresponsible.
So I think we can end with that of like we can pick it up on some teams don't know what that good citizen is, like that checklist, right? Of like what would be like setting requests, like those like what that's one example. But like you said, a lot, I would say like many or like many organizations that you said that like you said they're robbing Kubernetes on applications, so they don't know how to be a good citizen because just rob it. Like what good citizen, what being a good citizen means to the platform team. So the platform team is I think responsible to tell the development team like these are the guidelines to be a good citizen. And I think one example that can manifest from that tangible example is in Backstage there's a plugin which is scorecards that the platform team can tell the development team when they log into this dashboard for the application, they have a scorecard saying you're not putting requests and limits, you're not linting, you're not running tests, you're running maybe you're running databases on clusters and you should be running databases outside, and yet you have a scorecard. So maybe you have a little bit of gamification of like this line of business have a scorecard of 87, this other one has 97, and the upper stakeholder, right, VP of engineering saying like goal for this year is increase the scorecard across all the line of business, right? But that's what the platform team needs to put that tooling and that visibility of how well they're a citizen, right, of the platform.
Yeah, and there's other things too. So fun thing I have seen 3 times is TCP socket exhaustion from one tenant of a platform. which is a really fun thing. And if I could write a book on just how to identify that based on metrics, I would do that. But I think I would violate some NDAs.
Which
but
exhaustion? Sorry, I missed the first part.
TCP socket exhaustion.
Oh, networking. Okay.
Yeah, networking. I've seen it 3 times, which is a very low percentage for the number of clusters that I have looked at, like holistically. But it's something that I have seen that has a very unique presentation. Typically, it just looks like nodes crashing. And scorecards and so forth are not going to
capture
catch
that.
right?
Yes.
I don't know why my sound is hard for you to hear. It's a new computer. I'm going to
So
blame the new computer.
So that'll be observability of the runtime, right? And then exposing
Yeah.
that to the tenants. That
Yeah,
excellent.
it's just like some applications just opening up client socket connections and not closing them properly, or just
something that they can do in their applications to behave, be better.
NPM start is a really fun perpetrator of that. But yeah, so there's some things that the scorecards and the platform and so forth cannot account for, and it gets into the what are the resources that are shared through the cluster. Even when you do separation and node binding and all the other things, there's still aspects that are shared. CPU is shared, and so
CPU networking, inodes, running out of inodes.
Yeah, I know.
Little files. I've seen that myself. That's my SRE example. So I don't have an excellent example, but yeah, inodes burned me.